Today I've got one of the most fascinating plants. It is a carnivorous plant, and it possibly could take the record for the largest carnivorous plant in the world, and yet it's not widely known about, at least not in the sphere of carnivorous plants, because the way it does its carnivory is not as overt as something like a pitcher plant or a sundew plant, Venus flytrap, etc. Today's video is focusing on a relative of what you see on screen here, the Passiflora incarnata, and the reason we have that on screen is to further delve into how things evolved to make the carnivorous plant, of which this is a close relative, the way that it is. If you enjoyed this video, be sure to subscribe. I don't do that many plant videos on this channel, so it definitely would help out. But of course, without further ado, let's go ahead and talk about the Passiflora Foetida. Now, if you do not know about passion fruit plants in general, many of them are vining plants. They climb on various different surfaces, and many of these plants share some similar traits. One of those traits being these little glands at the base of many of the flowers and leaves, sometimes even appearing on the leaves themselves, called extra floral nectaries. In the case of Passiflora incarnata, you will find two of these glands at the base of the leaf where the leaf meets the petiole, and you will find anywhere from 1 to 6 or more of these glands at the base of the flower on structures called bracts. There are 3 in the case of Passiflora incarnata, and they're not terribly showy on this plant, but some plants like Passiflora umbilicata have very showy bracts. In that case, they're sort of a magenta color, a very attractive plant I'd love to get my hands on in the future, but that's in the future. In the case of Passiflora Foetida, though, these bracts have evolved to become these hairy, wiry networks. And there's a reason for this. Now, I said extra floral nectaries. What these do is they secrete a sweet liquid, at least in the case of Passiflora incarnata, Passiflora edulis, other species as well. And this liquid is there to encourage ants to take up this plant as a host, because the plant is basically banking on the ants to become their bodyguards as a first line of defense. This plant has other means of defense as well, notably some compounds in the leaves and in the flowers that can actually make insects go to sleep, which I think is quite hilarious and can work on people as well. That's a separate topic. But in the case of Passiflora Foetida, this plant has actually evolved, instead of having sweet nectar secreted at its leaves and around its fruit and flowers, it instead secretes a sticky glue trap liquid. That is the way that these plants function. Now, I said carnivorous. Just because a plant sticks to insects, that does not in and of itself mean that the plant is carnivorous. It needs to do a few things to be truly classified as a carnivorous plant. Right now, this plant is technically classified as proto-carnivorous, because I guess not all of the research is there yet, but the research that I have been able to find suggests that this plant does not only stick to insects, it digests them and absorbs their nutrients. And that's weird for this plant specifically, because it does not live in nutrient poor soil. Most carnivorous plants have adapted that feature because they live in nutrient poor soil. They are making up for the nutrients lost in the ground, and there are various reasons why that may be the case. But in the case of Passiflora Foetida, this is actually a vigorous growing, climbing vine, and it tends to prefer rich soil and moist soil as well. So why then would this plant go out of its way to develop carnivory? Is that not just wasted effort? Well, here's the thing. These plants already have the extra floral nectaries. They're already producing nectar. So seeing a changeover from a sweet sugary liquid to a more sticky liquid is not that far-fetched. And if you can understand the case here, these bracts, much larger than they are on something like Passiflora incarnata or Passiflora edulis, the bracts fully enclose the developing flower buds as well as the developing fruit. They're only really open for about a day or so as the flower itself is open. What are these bracts doing? Well, first off, if you think about a flower bud, what is it other than a meal, essentially enticing herbivorous insects to come and eat those buds, right? And so in this plant's defense, what it has done is it has created this near impassable network of sticky liquid and hairs that can quite easily entangle any number of insects, whether it be a caterpillar, a beetle, or whatever else might be trying to get at that juicy flower as it develops, or at the fruit as they ripen, because ultimately this plant wants to protect its fruit. It wants to spread its genes on to the next generation, right? But what's fascinating about this plant is that it chooses to be carnivorous in the first place. I say chooses as though it made its decision. What I mean, though, is evolutionarily. It seems like a disadvantage at first, because that is wasted effort, is it not? I mean, yes, it does absorb some nutrients, so hopefully it makes up for the nutrients nutrients it puts out in this secretion. But in this case here, the reason that it seems to be, this is partially just my theorizing here, but the reason that it seems to be carnivorous is not because it needs those nutrients, but rather it is trying to eliminate those nutrients from the environment. If you stick to a bug, if you cover yourself in fly paper, you're going to start to become a bit of bait for other scavengers. The flies might be dead if they were what's bothering you, sure, but then other things are going to come and try to pick those things off. Or you could have other things set in. If those flies are dead all over you, they might become infected with bacteria or fungi. And so in this case here, what this plant seems to be trying to do is reducing those nutrients available in the environment by just saying, hell with it, I'll just take the nutrients for myself. So not only does it stick to the insects, these are not moving traps, mind you, they're not active traps, they're passive, they are stationary. But if the insect is going to get stuck in it anyway, going to get entangled in it anyway, you might as well digest it so that those nutrients are not available elsewhere to other insects that might predate on your plant that maybe can bypass your network of sticky mesh, or to other animals that might try to come by and pick off those insects, like birds, right? They might try and pick off the insect but accidentally grab onto a part of the bract that rips the whole fruit off or flower off, and then suddenly you're out of flower, right? And many other things, like I said, bacteria, fungus, etc. So this plant seems to have developed its carnivory purely as a defense mechanism, and then another defense for its defense. It is truly mind-boggling that this is the case. Passiflora Foetida, as is similar with other passion fruit species, is a very vigorous growing vine, growing upwards of 30 or more feet in a single season. It can get quite large, and as a climbing vine, it can cover mounds of things, climbing up trees or on the sides of people's houses or along walkways and things like that. Outside of having things to grab onto, it might lay a little bit closer to the ground, and there are actually several species of Foetida as well. Foetida is its own species, but there's sort of like a subsection in the Passiflora genus for plants that do a very similar thing to this with this sort of carnivory property. I'll list them here in a moment. But I also had on screen here this Passiflora bonderi. And the reason that I have this one on screen is because this is also using its extrafloral nectaries in a really interesting way. Where Passiflora Foetida has opted to just eat whatever the hell comes along, right? Passiflora bonderi has done something different. It also doesn't want caterpillars to eat its fruit and its leaves and stuff. And so the leaves have evolved to look somewhat similar, at least on first glance, to a flying insect, especially to an insect that may not easily be able to see colors like green, right? But might see these red undersides and these stripes, this variegation, and think, oh, that's a butterfly. That plant already has a host on it, so I'll just go lay my eggs elsewhere. But further to sell that illusion, you'll see these yellow spots, and those yellow spots seem to have been evolved from these extrafloral nectaries, and they actually appear similar to butterfly eggs, specifically butterfly eggs that might make a host of plants like this. And so once again, if you're a butterfly and you think, well, that leaf's got 100 eggs on it, that leaf, that hotel is occupied. It's not, there's no vacancy there, right? There's too much competition. So I'll lay my eggs elsewhere so that my offspring, my caterpillars, have a chance to thrive on a meal they have to themselves. But in reality, this plant doesn't have any eggs on it. They're not butterflies around it. It's the plant tricking the butterflies that may try to lay eggs and lay their caterpillars on it. Because remember, caterpillars are just fucking factories that predate on these plants, right? That just consume and consume and consume. And so, of course, you want to do all you can to deter that. Once again, many Passiflora species, of course, do put out compounds that make insects sleepy or are toxic to insects, etc., right? But it is wild to me, all of the different methods. And there are hundreds of Passiflora species. What I'm showing you on screen here is just 3. It's about to be 4, and a list of more species here. These 5 other species are sort of a subsection of Passiflora Foetida, all of which having various amounts of this sort of carnivorous properties. If they all are carnivorous, I could not say, but at least some of them are. The research seems to have been done at least in part on Passiflora Foetida, though I don't know if it's like peer-reviewed studies or anything like that. Outside of that, though, the fact that these other plants also do a similar thing, also very close relatives of Foetida as well, having these bracts with the gluey, sticky substance on them. But looking here as well, Passiflora lutea. The reason I wanted to show this one here too is for 2 reasons. First off, Passiflora incarnata, the purple one off to the side of the screen here, is a native where I live in central United States, in the Midwestern United States. But it is actually has quite a wide range. It exists all the way down into Texas and Florida, probably even parts parts of Mexico as well, and all the way up even into parts of Canada. Is the second most hardy Passiflora species in the world, which makes it quite popular for hybridizing. It's also a very pretty plant, very showy. The flowers can be up to 4 inches wide, so very large flowers, native to where I live in Missouri. But it also has several other factors which make it an attractive plant. You know, it's got rootstock for other plants that might not be quite as hardy. Passiflora lutea is the most hardy of all passion fruit species, just a little bit more hardy than Passiflora incarnata. However, it's not super closely related to incarnata. It's actually closer to some other species as well, probably even closer to some of the batwing and butterfly wing type of passion fruit species, notably because of the flowers, but that's a separate thing. We'll talk about that in a minute. But Passiflora lutea is also native here in the United States, as well into parts of Canada. And you'll notice that these two plants here look reasonably different, at least in terms of the leaves. Variegation, which is quite common with this species. I have found some that have been variegated as well, and I've only found myself 2 Passiflora lutea species. So the fact that I found one that is variegated already shows that these are pretty common. This is a common morphology. I did not take these pictures. I found these on iNaturalist, a great resource. But these two plants here are the same species, and they exist only a couple of miles apart, maybe 5 or 10 miles apart at most, which is wild because they're the same plant. But when you look at the leaves, they do look quite different. Shape is similar, and I've definitely seen some lutea with much larger leaves that are even more round than this, a lot less lobed, where I've also seen some lutea where the lobes are much deeper as well, almost not, there's almost hardly any leaf there. And so it's wild to see the strategies that this plant has evolved in its own species, in the same species as well. Lastly, before I end this video, there are some other lines of defense that this plant has, because ultimately, if this plant is a host to insects like ants, right, you don't want the ants to get inside of the flowers themselves and get to the nectar, right? You want to entice the ants with a mint on their pillow, not to come down to the free buffet, because that buffet is for the insects that can actually pollinate these flowers. Ants can't. They're too small to actually get up in there and pollinate them. I mean, I guess they technically could, because like, what's going to stop them? But there need to be a lot of things that went right for an ant to actually pollinate one of these flowers. So these coronas, these filaments that go all the way around the flower here, do a couple of things. They signal as a bullseye towards flying insects that, hey, you need to land here to pollinate this flower, to get that nectar that you so desperately want, right? But ants want that nectar too. However, ants, most of them, do not fly, so they're going to have a much harder time getting on the top side of the flower with all those filaments in the way, especially understanding that there's not just one row of filaments here, but there can be dozens depending on the species and depending on the flower, right? In this case here, this flower has a lot of rows, like shark teeth, think of it that way, rows of these filaments as you get closer and closer to the center, and they become more tightly packed, more tightly woven. That's very difficult for ants to get through, but an animal with a proboscis, like a butterfly or a bee, can very easily get down inside there and get to the nectar because it just pokes around with its proboscis. Ants don't really have that, so they don't have a lot of luck getting in here, and thus the ants are going to stick around to the other parts of the flower and the other parts of the plant that are just giving it the nectar anyway. Wild to me that these plants go out of their way to do something like this. And of course, Foetida, once again, even harder for ants to get to that nectar if you've got these sticky glue traps that an ant would have to crawl all the way around before then getting to the corona and trying to further crawl around that as well. Absolutely wild amounts of evolution and adaptation to make sure that these plants are able to do everything they want to do to ensure that their next generation wants to survive. So if you did enjoy this video, be sure to subscribe because it does help out the channel tremendously. And of course, I don't produce that many videos talking about plants specifically on this channel, so it's much more helpful if you do subscribe to this one. But of course, if you are interested in these plants, I'd highly encourage you to look out for them, do a little bit of your own research. Like I said, more than 500 species of Passiflora just in the Passiflora family, or rather genus alone. And there are many other genus in the Passiflora family, separate thing. Anyway, so be sure to check those out. Let me know your favorites, specifically if you live near any of these species. Foetida, once again, southwestern United States, as well as through Mexico, Central America, South America. Passiflora incarnata, most of the central and eastern portions of the U.S., parts of Canada, even into northern parts of Mexico as well. And once again, similar distribution for Passiflora lutea too. Anyway, I will see you all in the next one. Let me know your thoughts down in the comments below. Take care.